Bismillahirrahmanirrahim. Assalamu alaikum, students. In the last lecture, I introduced you to the idea of function. First, we discussed the idea of a variable. We said variable can represent any one of a given set of numbers, but the constants which we represent by letters A and C, etc., they represent a single number. Then we define set as collection of objects which may be mathematical or not, or we said that collection of distinct and well-defined objects is set, and the elements or members of the set are called elements of the set. Then we said an variable can have a range. It can represent a lot of numbers. Then we define function. In the function, we said it is a correspondence xy between two sets of numbers which bears to an arbitrary number x of the first set exactly one number y of the second set y. When correspondence is this way, that we have two sets, set y and set x, and the correspondence relates every member of x to a unique member in set y, we say this rule is a function, right? Then we explain the idea. Then we discussed that we can express these correspondences by means of a mathematical equation or by means of a table. We discussed this table. If y is equal to x plus 2 is some function, you can represent this function through this table. If your set x contains numbers 1 to 10, then the values of the function for these numbers are listed in this table: 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we can express these correspondences in the form of a table or by means of an equation. Then we said a function is single valued if to each value of y in its range there corresponds just one value of x. If there are more values of x corresponding to each value of y in the range, then the function is multi-valued. For example, y is equal to x plus 3 is a single valued function, but y is equal to x square is a multi-valued function, because in case of y is equal to x square, if you take the y as 4, x can be 2 or minus 2, right? If you take y as 9, x can be 3 or minus 3. So y is equal to x square is not a single valued function. It's a multi-valued function. In fact, it is a two-valued function, right? Then we discuss what is the meaning of f of x. It is just the value of the function when the x attains the value x. So if x is 3, then we say function is f of 3. F of 3 means the value of the function when x is 3. So we use this function x square minus 5x plus 4, then found the value of the function at x is equal to minus 2 and x is equal to 3, right? Then we said that the set of the values of the independent variable x is called domain of the function, while the set of the values of the independent variable is called the range of the function. For example, in this table, the set of the values of x, independent variable, this is domain. So this set is your domain, and this set is range of the function y is equal to x plus 2, right? Then we move further. we talked about bijections. We use this color. We said if there is a function y is equal to f of x such that for every y in the range there is one and only one x in the domain, then function f is called one-to-one correspondence or bijection. Now, there was a mix-up between single valued function and bijection. Remember, all bijections are single valued, but all single valued functions are not necessarily bijections, right? So, single valued function is different than a bijection. So, bijection is a single valued function is not necessarily a bijection. Now, today I want to differentiate uh, or clarify the meaning of bijection. I repeat, I am saying uh, don't mix the idea of single valued function with the idea of bijection. And we said all functions of this form x plus by plus c is equal to 0 are bijections. Then we said y is equal to x square is not a bijection, but y is equal to x cube is a bijection. So let me make clarification. So you need to remember that single valued function is one thing, bijection is another thing. Then we did certain questions. So today we move forward. It will get page to this. Let me use this color. So in mathematics, we talk of injections, surjections, and bijections, right? Now, what are injections, surjections, and bijections? They are simply classes of functions distinguished by the manner in which arguments, by arguments we mean input expressions, input expressions are in the domain. So input expressions from the domain and and images images are output expressions, and those output expressions are in which set? They are from the codomain are related. So we define injections, surjections, and bijections. They are simply functions in mathematics, and we distinguish them by the manner in which arguments, by arguments we mean input expressions which are in the domain set, and images which are output expressions which are in the codomain of the function are related. So let us understand it. And remember this when we defined function, this correspondence. For example, here we define the function this way. We can express this definition of the function, or we can express any function using a Venn diagram, right? For example, if there is some rule which relates to sets, it is my set X, it is my set Y, let the elements of set X be 1, 2, and 3, and the elements of set Y be A, B, C, D, and E, for example. If there is a rule which connects 1 to, for example, B, 2 is also connected to B, 3 is connected to, for example, D, does this rule qualify for function? Can we say this rule, which is embodied in this Venn diagram or represented by this Venn diagram, is it a function or not? See, this is a function. You can see because your definition is satisfied. We have two sets, set X and set Y. Condition is it should pair to an arbitrary number X of first set exactly one number Y of the second set. So in set X, no member should left behind. That means the correspondence must connect all the members of set X. So 1 is connected, 2 is connected, 3 is connected. We say it should pair to an arbitrary number X of the first set, exactly one number of Y of the second set. So you can see 1 is connected to B, it is not connected to any more member of set Y. 2 is connected to B, it is not connected to some other member also, right? 3 is connected to D, it is not connected to some other member also, right? So this correspondence uh, is a function. It is a function in general. It is a function. So when we say it is a function because it satisfies the definition of the function, then we define domain, codomain, and range, right? Here set X is domain, set Y is codomain. But when we define range, range of this function is that set which contains images only, B and T. This is range. So it can happen that range and codomain are different. So in general, you can see range is subset of codomain, right? Range is subset of codomain because range is the set which contains images only. Remember, we use this language. We say B is the image of 1, B is the image of 2, D is the image of 3, according to this particular rule or correspondence. And sometimes we say 1 is the pre image of B, 2 is the pre image of B, 3 is the pre image of D. So first function, if the correspondence is function, that means every member of set X left set in the Venn diagram, every member must be connected and every member must be connected to exactly one number of codomain. Right. Then we talk of domain, codomain, and range. range in general is a subset of codomain, right? And let us move to the idea of where is my next page? Injection, surjection, and bijection. So this was the general idea of a function. So let me define injection. Use another page. So the function we define first, injection. So the function we call it injective function also. The definition is the function is injective. It's also called one to one. What is the condition? If each element of the codomain is mapped, corrected or mapped, is mapped to at most, understand it, one element of the domain. This is the condition. If we have a function and it is such that each element of the codomain is mapped to at most, is to be underlined, one element of the domain, then this function is called injective, or we call it injection. Let me clear it. For example, if I show function this way, there is some correspondence represented this way. I have set x and set y. In this set, there are, for example, three numbers 1, 2, and 3, three members. And here I have A, B, and C. Three members are in set Y. So if one is connected to A, two is connected to B, three is connected to C, right? Or let me make another Venn diagram. I have two sets like this. This is my set X, this is my set Y. This set contains members 1, 2, and 3. Here I have A, B, C, and D, right? One is connected to A, two is connected to B, three is connected to C. Now we want to understand all these first functions. They are of course functions because there is no member of X which is left behind, and each member of X is connected to exactly one member of Y. So this is a function, this is also a function. So in this particular function, we have domain as set X, codomain as set Y. Set Y is also the range. In this function, set X is domain, set Y is codomain, but range is a set which contains three members A, B, C. So here range is the subset of codomain. Now, are these functions injective or not? Let us go to the definition. If each element of codomain is mapped to at most one element of the domain. So you can see in both situations, this condition holds true. In first situation, A is connected to 1, it is not connected to some other member. This condition is each element of codomain should be mapped to at most one element of. So number of elements in set X which can be mapped to each element of Y, its upper limit is 1, right? So both of these functions are injections, right? In codomain, so they are both injections, right? They are both injections. There is no member in the codomain which is connected to more than, mapped to more than one element in the domain. So both are injective, right? Both of these functions are injections, right? Both of these functions are injections. So let me move now to another thing, that is surjection. Surjection. What is surjection? So the function is surjective, or it is called ONT also, if each element of the codomain of the codomain is mapped or connected to at least one element of the domain. So the definition of the surjection is the function is surjective. It is also called onto if each element of the codomain is mapped to at least one element of the domain, then it is called surjection or surjective function or onto function. Differentiate here with injection. Here definition was each element of the codomain is mapped to at most one element of the domain. Here we say each element of the codomain is mapped to at least one element of the domain. So differentiate this at least with at most in your minds. Let me show you what is the meaning of that. So if there is function this way, I have set x, I have set y, and there is one member 1, 2, 3, and 4. It has 4 elements, and then there is D, B, and C, for example. Now, 1 is connected to D, 2 is connected to B, 3 is connected to C, and 4 is connected to C, right? So this go to let us see whether this function, first it is a function. Now let us see that whether this function is a surjection or not. Let us move to the definition. Each element of the codomain is mapped to at least one element of the domain. You can see D is connected to 1, B is connected to 2, C is connected to 3 as well as 4. But the condition is it should be connected to at least one element of the domain. So C is connected to two elements. C is mapped to two elements in the domain, 3 and 4. So there is no issue because condition is it should be mapped all members. First, you understand no member of codomain must be left behind. So no member of set Y is left behind. The question is, definition is each element of codomain is mapped to at least one element of the domain. So all elements of Y, that is codomain, are connected, but each must be connected to at least one element. That means all should be connected and each should be connected to at least one. So C is connected to two members of the set X, which is the domain. So there is no issue. This is a surjection. This function is surjective, or we call it on, right? So let us move to now the another thing, which is the bijection. Bijection. Now, what is the definition of the bijection? This bijection is defined as a function in which each element of the codomain, each element of the codomain is mapped to exactly one element of the domain. Okay, the color. So this is the definition. If there is a function in which each element of the codomain is mapped to exactly one element of the domain, then this function is called bijective or one-to-one and on. Sometimes we call it one-to-one and on, one-to-one and on. We call it one-to-one correspondence. We call it also invertible function. If you look into this definition, this function, which is bijection, is both injective and subjective. Both injective and subjective. Differentiate. In surjection, we have a condition that each element of codomain is mapped to at least one element of domain, right? In injection, we have a restriction that each element of the codomain is mapped to at most one element of the domain. So there is at most and at least situation, and uh, in let me give you further thing. In injection, there is no element of the codomain which is not connected to, and it should be connected to. Sorry, when we say injection, there can be some element in the codomain which is not connected. But in surjection, though no element in the codomain is left behind. So remember, in injection, there can be a member in the codomain which is not connected. But in surjection, there is no element in the codomain which is not connected. And let's move to the bijection. In bijection, each element of the codomain is mapped to exactly one element of the domain. So let me show you that example. So if you see this example, this is injection, right? This is surjection also, this particular thing. This is injection as well as surjection. So this function is surjective also. So it is injective, it is surjective also. Therefore, it is bijective. That is, it is bijection. Let us move to the definition. Bijection says each element of the codomain is mapped to exactly one element in the domain. So you can see in this function, this particular example, each element of the codomain is connected to exactly one element in the domain. So no element in the codomain is left behind, and each is connected to exactly one. So it is a bijection. It is an injection. It is surjection also. Why it is surjection? Because it satisfies the definition. So this form, because surjection says each element of the codomain is mapped to at least one element in the domain. So it satisfies that definition. So this is surjection, this is injection, therefore it is bijection also. So those functions which are injections and by surjection simultaneously or bijection. So let us talk of this function. You see, in this function, it is injection, as we told and we discussed previously. This function is an injection, but this function is not a surjection, so it is non-surjective. Why? Because in surjections, you have no element in the set Y which is not connected, which is not mapped. In this, we have a member D which is not connected, so it is non-surjective. So this function is injective, it is injective, it is non-surjective, therefore it is non-bijective. It is not a bijection, not a bijection, right? Let us move to the first general situation which we define. What about this? Is it surjective? No, because there are two A, C, and D, three members, then why they are left behind? So it is non-surjective. It is non-surjective, isn't it? What about, is it injective? Is it injective? It is non-injective. Why? Because you can see 1 and 2 both are connected to B. In injections, that is not possible. Because in injection, we say, let me move to the definition. In injection, we say each element of the codomain is mapped to at most one element of the domain. At most. But here you can see there is an element in the codomain which is connected to two elements, 1 and 2. So it is not an injection. So it is non-surjective and non-injective. Non-injective. So therefore it is non-bijective. It is not a bijection. It is not a surjection. It is not an injection. So it is not a bijection. So let me move to what about this? We discussed this. This is surjection as well as injection. Therefore, it is a bijection. This is non-surjective. It is injective, but since it is non-surjective, it is not a bijection. Right? We discussed this. What about this? It is it injective? It is surjective. But what about this? Is it injective? No, it is not injective. It is non-injective. Non-injective. Why? Because there is a member C in the codomain which is connected to two elements. But in case of injective functions, this should not happen, right? In injections, we say that each element of the codomain is mapped to at most one element in the domain. So it is non-injective. So I can say it is surjective only. It is surjective. It is non-injective, right? So you can say it is surjective only. Since it is surjective only, it is non-bijective. It is non-bijective. It is not a bijection. So I hope the things are clear now. So idea of single valued function is a different. Idea of bijection, injection, and surjection is a different, right? So you can first you have to now distinguish between first well first you have to decide whether correspondence is a function or not. Once it is a function, then you talk of codomain, range, and domain. Sometimes codomain and range are equal, like in this example. This is range, this is also codomain. Sometimes codomain is a bigger set, so range is subset of that. So you stick to the definitions, then you will not get confused. So in case of single valued function, when we say function is a single value, this should happen to each value of y, there should correspond just to one value of x, right? Now you see, when we talk of bijection, let me go to this Venn diagram. This is the bijection. you can see to each value of y there is a single value of x. Each value of y there is a single value of x, that is a single valuedness. And we said defined the single value function. We said that function is a single value if to each value of y in the range there corresponds just one value of x. So for all values of y there is a single value of x. So you can see all injections are single valued. When it is an injection, it is a single valued function, right? But it is not necessary that there is a single valued function. uh, it's not guaranteed that it is what I should say, when it is a bijection, it is a single valued function. So you have to stick to, but if it is a single valued function, it is not a necessarily bijection, right? For example, this is, if you go to this example, uh, this is a single valued function. For each value of y, there is a single value of x, but it is not a bijection because there is a member d in the codomain which is not connected, right? So I hope now things are clear to you. You now know what is a function, what is range, what is codomain, when function is bijection, when it is injection, and when it is surjection. Stop here and conclude my lecture. So don't forget to like, share, and subscribe my channel. Thank you. Assalamu alaikum.